Hello everyone, welcome to this video. My name is Amir Ahari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how we can identify dry days and wet days using precipitation data with daily temporal resolution in the Google Earth Engine platform. The definition of the dry and wet days might be different in different locations in all around the world. But at least in my own country, Iran, those of days with precipitation less than 1 millimeter per day, we can say that, okay, today is a dry day. And for those of days with precipitation greater than 1 millimeter, we say that this is a wet days. And there are variety of classifications for the precipitation regarding to the precipitation classes. And also by the techniques I'm introducing in this tutorial, you can do any other kind of classification for the precipitation data that you have for your study area based on your criteria. But the technique is very important, and now I will show you how we can distinguish data from the wet days and also the dry days. For the first step, find your location of the interest. For example, in this tutorial, same as most of them, I want to select a region from the north of Iran where we have more precipitation compared to the other part of country. So, for example, here in the north of Iran, I select my study area like this by drawing tools available here. I draw a rectangle here in the Alborz mountainous region in the north of Iran. I select a specific region for this tutorial. And also you can pick any location or everywhere in all around the world for this tutorial. It doesn't matter you are working on Iran or any other countries in all around the world. Just important to learn the techniques I'm telling you in this tutorial, and then you can use it for different classes, for different thresholds and different locations in all around the world. So make a focus on your study area. Throw the map.center object. Map.center object, make a focus on the study area that is located by the drawing tools and entitled as geometry here. Then we need to call daily precipitation data through the search places and dataset. As I mentioned in the previous video, if you watch them in my YouTube page, there are lots of videos that I'm using search places and dataset to find the appropriate data. So through here, go to browse data catalog and then browse data tags. Here you can browsing your desired data based on different tags. For example, I want to work with precipitation data and throw the filtered dataset tags. Here I'm writing precipitation as a keyword. As you know, the precipitation including the rainfall and snowfall. If you want to work on the rainfall only, you need to type rainfall instead of the precipitation, just like that. But here, I want to work on precipitation data. You can see that different sets of data collections are available for the precipitation data analysis, and you can have access them, some of them estimated directly from the satellite by the satellites, and some of them assimilated by the combination of the satellite and in situ measurement. You can see, and these are available. One of the most famous product for the precipitation is a Persian product. As you can see here, in the Persian precipitation product is available from the 1983 and produced by the NOAA, and with 27,000 meter spatial resolution provided daily precipitation with millimeter units. For example, I'm gonna use this product for identification of the dry and wet days. So it's very simple. You can call Persian data through the search places and dataset. Here, if you write Persian, you can see that its product is available, import into the code, and entitled as an image collection here. Make a new variable entitled as, for example, PR, meaning precipitation here, and then assign image collection to the PR. And then you need to set filter date. Throw a time start and time end. For example, for 10 years, I want to identify which day is wet and which day is, for example, dry. So here I set time start and time end just like that equals to, for example, from 2010 to 2020, 2010 to 2020, we want to identify the dry and wet days. So only we have one band and no need for the band selection anymore here. And as we are working with the coarse spatial resolution data, it doesn't need to use filter bound or something like that. Try to write your code as simple as you can, because we want to have a light programming steps. We want to avoid from heavy programming in order to increase the speed of processing through the Earth engine. So now for the next step, I want to get a print from the precipitation to see that how many precipitation or daily precipitation data available for 10 years. More than 3,600 precipitation data available over these 10 years. And now for each image, I want to calculate the average of precipitation rate in this area and then filter them, which one has lower precipitation than, for example, 1 millimeter, and which image including average precipitation greater than 1 millimeter. To do this, it's very simple. Just make a new function to write this program. So we have a function here. For example, this is PR class, and this function has one argument. It is image collection. Each image, including in the image collection, will be go to this function and entitled as an img here, and then through the parentheses here, I will show you how we can write a function, a simple function, to calculate the average of precipitation for this selected region. So here, make a new variable. For example, here we have mean or average. You can call it as PR mean. Average precipitation for the location of the interest. Get from each input image as an img, and then through the reduce region, just like that, through the reduce region, we can reduce the values over the region to a single value. And there are different arguments that is necessary for the reduce region. The first and the most important one is the reducer. A reducer, for example, we want to get an average. The reducer should be mean. And the next one is the region of the interest, that is defined by the geometry argument, and the name of the location of interest is the geometry, like that. And another important thing is about the scale, the spatial resolution. A scale defined based on the spatial resolution. As I'm working with the satellite image with a 27,000 meter spatial resolution, we need to set 27,000 as the scale here. And then to get the average value, use that values from the first band that gets 0. Just like that. So by this code, we get the average value for each image. For the next step, I want to set the average value that is extracted as a property for each element available in the collection. For example, here we have a big image collection, more than 3,000 images, and each feature or each image has some metadata information that you can see. It's like mount, system time star, and on it goes. And now when I derive the average value for the region of interest, I want to add this value as a property for each input images. And then we can filter the wet and dry days based on. For example, here in the function, just you need to return each input images with the normal properties that it had before. For example, img.property names. So nothing happened so far. Just in the next line, you need to set a new property. When you want to define a new property, .set is a function you need to use. .set, the property name here, for example, is prmean, and also you can pick any other names you prefer, and then set prmean value to this property. Just like that, it's very simple and easy to use. So the function now is ready. Just we need to apply this function on each data available in the PR value. Make a new variable PR, for example, for example, you can use different names here. For example, PR class equals to, or PR values, I think it's better, equals to PR get the precipitation data and throw a loop that is defined by .map. We can apply PR class on each precipitation data available. When I print the PR values, I expect to have a new property for each image available under this image collection, showing the average precipitation for the region of the interest. And then you can save your code and run it again. Here we have a new image collection. It's under computing because we applied a new function to get the average value and set its value as a new property for each available image here. So for each feature, now we have that same precipitation band, and also nothing changed regarding to the band, same precipitation band, but now we have one property new here. This is prmean, the average of precipitation based on millimeter for the region we selected. So you can add more statistical criteria regarding to the precipitation. You can use this technique to add maximum precipitation, minimum precipitation, or something like that, or a standard deviation. It depends on your goal. And also this technique is very, very useful for the frequency analysis in the Google Earth Engine platform, and specifically for the climatological data analysis and hydrological data analysis, and also for the drought monitoring. We want to know that, for example, how much dry days increased, or how much dry months increased, or how much wet days decreased, and we can get different queries based on. So back to the code, and now I give you an example. For example, we want to get the maximum precipitation, PR max. Here, new variable with the name precipitation max, Earth engine.reducer.maximum, and then we can set a new property here with the name PR max and the values of PR max. It's very simple, and also there is no challenge, and by the reducers you can have access to the variety of statistical functions here for the regions you selected. And also, if your location of the interest is a point, for example, imagine that we don't have a rectangle here and we want to get a precipitation value for a point. If you want to get a value for a point, would be better to use Earth engine.reducer.first, because when you are working on a specific point that we want to get the first value or the closest value to the point selected. That's important. But when you are working with the rectangle or polygon, would be better to use average, maximum, minimum. It depends on your goal. So let me to back to the rectangle region. I had selected here by the drawing tools. Then I draw a new rectangle, and again you can save your code and run it based on. So in the next step, we want to set a filter based on the new properties we have to differentiate the dry days and the wet days. So here, for example, I make a variable, for example, we named as dry equals to PR values actually, because PR values including the new property, the average precipitation for each date. Whenever you want to filter data based on the properties, it's very simple to use different types of the filtering to have your desired data. For example, here I make a new filter, Earth Engine filter. I want to have those of images in which precipitation average for the region of the interest was, for example, below than 1 millimeter. So less than filter helping very well here. Filter.lt, this is less than filter, and we want to say that less than for precipitation mean. The property, the target property here is PR mean, less than what? Less than 1. And according to the unit that here for this data is millimeter, 1 here meaning 1 millimeter. So now I want to get a print from dry image, and we are waiting for computing to see the results. The results only showing the dry days from, for example, 3,600 days. More than 2,000 days have had the average precipitation lower than 1 millimeter. And also you can have access to the dry images, and also you can do this code or try this code again, but this time for the wet images. This is dry values, and also you can change the threshold based on what you based on your reference, because in different references, as I mentioned, there are variety of classifications and thresholds about the extreme precipitation, dry days, wet days, and something like that. And also feel free to do any changes in this code. But the only thing matter here is that you know how to define a new property based on, and how to filter it, and how to filter your target data, how to get the query based on. It's very important to know in this tutorial. And also you can use this kind of technique for a variety of satellite data products available in the Google Earth Engine, about the soil moisture, about the for example, about the soil moisture, about the temperature, about the NDVI. You can use it for the variety of the products, and also it is completely independent from the satellite and the type of data you are working in the Earth Engine. The only thing is that the data you are working should be an image collection to add a new property and to filter data based on. So For example, I want to set dry days with a new threshold, 0.5 millimeter per day, and I want to make a new plot based on, for example, here I make a new plot to plot only dry days, the dry day values, and see the distribution and see that how the dry days values for the precipitation changes. For example, and also for sure most of dates precipitation is 0 and we don't have meaningful value for the most of the dates, but now you can have access by this method. You will have access to the dates in which we had a dry condition, and also you can have access to the least number that is recorded for the precipitation actually, or least value recorded for the precipitation in this date. User interface .chart .image .series, and through the instead of the image collection we have dry days or dry images, and instead of the region we will have the location of the interest and the reducer replaced by Earth Engine reducer for example average, because we already got an average and now we want to plot this data based on the average, and the scale could be 27,000 meter equals to a spatial resolution, and instead of X property we have system time start, just like that. And then set chart type, because it is because the precipitation has discrete nature value, and you need to would better to turn the set chart type to a column chart, just like that, and run the code again. Wait for generating chart is generating. After a few seconds you can see the result, and you can have access to the dates in which precipitation was less than 0.5 millimeter, and you can see that the range of the values varies from 0 to 0.5, just like that, because we use the less than function. And then here you can see that the maximum value is 0.5, and you can download the Excel file available here. But as I'm working with the Macintosh, maybe the result will be opened in the number software, but as it has the CSV format, you can easily open it into the Excel and check it out. As you can see, just those of dates that precipitation was less than 0.5 millimeter. It's very interesting things, and also you can do variety of further processing in the next step based on these valuable data. Or for example, we want to have another class to get those of dates that precipitation was greater than, for example, 1 millimeter, and entitled as wet days. Here I make a new variable here as a wet equals to, for example, PR values that filter Earth Engine filter. For greater than we have GT, those of images in which PR mean average precipitation is greater than, for example, 1 millimeter per day, and then we can print it by chart to have access to the values and to the date simultaneously. So user interface .chart .image .series. So we have wet, and the region is the geometry, and the reducer will be the average, Earth Engine reducer mean, and the scale should be 27,000 meter, and X property replaced by system time starts, and then set chart type as column chart. Run the code again. The second chart is generating. lower number of images available for the wet days because the rate of precipitation in Iran is lower than, for example, European countries and some Nordic regions. So here you can see that those of days rate of precipitation greater than 1 to, for example, 45. The maximum is 45 millimeter. We have some extremes here. In January 8, 2016, the rate of precipitation for one day was more than 40 millimeter per day. And so it was awesome and for this region. And actually, here the new CSV file is available for those of dates in which precipitation rate was greater than 1 millimeter. And yes, you can see that the greater than 1 millimeter for all dates is available. So, and also that was a method we used for filtering the precipitation data. And also it's very important to know how to extract the values from each input images here, as I mentioned earlier. And another important thing is how to set a new properties here. And also it should be, and also you can in the Earth Engine define some sort of filters, for example, for a specific range. We want to, for example, imagine that we want to call those of images that the precipitation rate is between 0.5 to 1 millimeter. So to do this, make a new variable as a mid class, for example. I make a new variable, for example, this is a mid class between 0.5 and 1, and I have no references for the values or thresholds I selected here. These are just my assumptions, and also you can change the thresholds based on the existing literatures and references. And also just should be noticed that these values not scientific, just simple training. So mid values equals to get PR values, and then we can define if a new filter, Earth Engine.filter gets those of values that greater than equal 0.5 here. For example, PR mean is a target properties greater than equal 0.5, and then we can make a new filter to filter it again and just keep the data that precipitation average in them are less than, for example, 1 millimeter. Dot filter Earth Engine dot filter dot less than equal. Target is precipitation mean less than equal to 1 millimeter, and then print the result. Print the mid class. In the right panel, image collection is computing. 300 images available, and for each you can see that into the properties you can see that the rate of precipitation is less than equal 1. I mentioned less than equal 1 as long as there is 1, maybe oh, this is maximum actually. You can see that the average precipitation is, for example, 0.9. To check it more accurately, we can just print the average values by aggregate array. For example, by the aggregate array, you can have access to the list of only one property in the Earth Engine. These are very useful techniques for the making query in Earth Engine platform, because it's very simple. By filters, you can filter data and collections based on different type of the filters you can define. You can see that all of the values ranged from 0.5 to 1, and also no values above 1 or no values below 0.5 millimeter units. It's available, and also then you can make its charts same as the methods that I have already explained here. And I hope you like this tutorial as much as I do. And if you had any questions or problem regarding to the processing steps and programming, feel free to reach me out and put your comment in my YouTube page and ask your questions. I will try to help you, and also I will put the code link in the GitHub below the video in the descriptions. You will have access it, and I hope you can learn this code and use it in your own project. Don't copy the code because it's not a useful method to helping you to learn. If you want to learn, you need to write the code by your own and learn about the functions. And Google Earth Engine provided a good platform for the non-programmers. We are, for example, remote sensing scientists, environmental scientists, and also our job is not programming, and in the Earth Engine there is a good chance to use the simple script to write own programs and extract valuable information we needed in our research papers or in our projects. Keep in touch, and thank you for watching us.